As of now, we had seen how to actually create a linked list and how to traverse a linked list. Now there are so many other methods that we have to see in this particular linked list, like how can we add an element at the starting of a linked list, or add an element at the end of a linked list, or delete an element from a linked list, or search an element in a linked list. Now to understand all of those things very easily, there are certain properties that we need to understand in case of linked list. So first let me get the linked list over here that we had created. Now in this linked list, if you do observe this linked list carefully, you will easily find out certain properties. So let me show you properties one by one. So the first thing is, in this particular linked list, every linked list will have one reference, and that particular reference is what we call as a head. And this head will always will be always pointing to the first node. And in case if the linked list is completely empty, if you do not have any elements in the linked list, in that case the head will be pointing to none. So this is one particular property. Now one more thing that you need to see is, the linked list is nothing but the collection of nodes. So if you observe this particular linked list, there are 4 different nodes in this particular linked list. And every node has 2 parts. If you observe this particular node, it has 2 parts. One is the integer value and the other one is the reference of the next node. Same thing with this. One is the element and the other one is the reference of the next node. And that goes with all of the nodes apart from the last node. And that's the next property. And what's the last property is nothing but, whenever you observe the last node have 2 parts. One is the element itself, that is integer value in this particular case, and the other one is the reference to the next node. Since this is the last node, there is no next node. So that's the reason the next part of the last node will be always equal to none. So what are the 3 properties? The first one is, there is a reference called as head which points to the first node of the particular linked list, and in case if the linked list is empty, the head will point to none. And the second thing is, every this particular linked list is collection of nodes, and every node has 2 parts. One is the data and the next node. And the third property is, the last node doesn't point to any other node because that's the last node, and the next part of the last node will be always equal to none. So when we actually start writing different methods in case of linked list, there is a certain scenario which keeps repeating multiple times. And which is that scenario, if you ask me? If you have a linked list like this, there will be definitely a scenario where you will have to traverse from the starting of the linked list till the end of the linked list. Now, how do you traverse a linked list? We have already seen in the previous program, but to standardize this particular thing, let's see a particular scenario. Now in case I need to traverse from starting of a linked list till the last node, if I have to traverse like this, then what is the condition that I need to write, and how is the loop that I have to write is a major question. So what I can do is, in case if I have to start traversing from the first node till the last node, in that case definitely I would need one reference, and that reference will be of type node. So let's assume the reference is nothing but current, and it starts pointing to the first node. So who is pointing to the first node? Head is already pointing. So whatever is there in head will also be placed inside the current. So current also starts pointing. Now what is that we need to do over here is, we need to make sure that the current moves to the next node. Now how do I ensure the current moves to the next node? Very simple. All I have to do is, whatever is there in current.next. So what is there in current.next? It has the reference of the next node. So the reference of the next node should be placed inside current, so that the current is actually pointing to the next node. So all I have to do is, I need to say current is equal to current.next. So whatever was there in current.next gets stored inside current. So what was there in current.next is nothing but the reference of the next node. So current starts pointing to the next node. Now the same thing has to be repeated. So if the same thing has to be repeated, then I will have to put this particular statement inside a loop. So which loop I am going to make use is nothing but a while loop. So I'll say while, and what is the condition I don't know as of now, but let's start traversing and see what exactly could be the condition. So as of now, over here, what exactly is happening is, current is pointing to this node. Is it the last node? No, it's not the last node. If it's not the last node, I need to repeat this statement. So what happens? Current is equal to current.next. In that case, the current moves from here and points to the next node. Now check whether this is the last node. We can clearly see this is not the last node. Since it is not the last node, I need to traverse this once again. So once again, if I execute this statement, that is current is equal to current.next. So the current.next starts pointing to the next node. Now if you ask, is this the last node? Yes, it is the last node. Now, how do I know it's a last node? By seeing, I can say this is the last node. But how can I programmatically say this? Very simple. You can clearly see in the last node, the next part will be always equal to null. So, when the next part is equal to null means current dot next is equal to null, I should not repeat this operation. So when should I repeat this operation if you ask me? Whenever current dot next is not equal to null. So you can clearly see over here current dot next is not equal to null. Over here current dot next is not equal to null. So I am repeating this. Over here current dot next is not equal to null. So I am repeating this. Over here current dot next is equal to null. I should not repeat this. So what is the condition if you ask me? Current dot next is not equal to null. And if I write this particular while loop, it will ensure that the current will move till the last. Now, there might be other scenarios that I do not want the current to move till the last node. Rather, it should move till the last second node. So, what I am going to do is I am going to duplicate this particular linked list. And over here, let's see that particular scenario once again. Now, what I need to do is I need to ensure that the current dot next is not equal to null, and I will repeat the same operations what I have written over here, but with minute changes. Now, how can I do that? We will see this step by step. So basically what has to happen is current should not point to the last node, rather it should point to the last second node. Now if I have to say the condition directly, this is how it will look like. You can observe one thing over here. The current dot next is not equal to null, but dot next, if I say, it is equal to null. So what is the condition that I need to write if you ask me? The statement remains as it is. The only change that I need to do is current dot next is not equal to null. If that is the condition, then I need to, if that's a condition, I need to repeat this. If it is not the condition, I need to stop repeating this. Now, if I trace this particular code, we will understand this, how exactly it works. So, at starting, what happens is, current will be pointing to the first node. That's nothing but wherever the head is pointing. Then what I will do is, I will check the condition. Is current dot next dot next. Current dot next is this, dot next is this. Is that not equal to null? No, it's not equal to null. So what happens? It repeats. Current moves from here to here. Now what I am doing? I am checking is current dot next is this. Is it not equal to null? No, it's not equal to null. So current condition is true. Condition true means it moves. So what happens? The current will move from here to here. Now again I am repeating the same operation. I am checking the condition. Current dot next is this. Dot next not equal to null. Dot next is actually equal to null. So the condition fails. Once the condition fails, it comes outside. Once it comes outside, you can clearly see current is already pointing to the last second. So I hope these two scenarios are completely clear to you. And now on, whenever we are writing different methods or whenever we are defining different methods of linked list, in these particular cases, we will be definitely seeing these particular scenarios.